0.1 grams, a ruler with 1 millimeter increments, a wire brush to remove the char from the test specimen, and 18 millimeter clips with the weight of 3 grams. We use a ring stand and clip as shown in the illustration. We also have a metal bar attached at the base of the chamber to push the fixture against, so we have the same measurement from the sample at each flame application. When the test is started, the air vents for the burner are completely open. The gas flow is set to correspond with the airflow of 895 milliliters per minute and the methane flow of 1205 milliliters per minute. The pressure should read 2.5 psi, and the flame should be about 100 millimeters high in the vertical position. 10 test specimens cut length parallel to the lengthwise direction of the material. 150 millimeters by 400 millimeters are used for each test. Multi-layered specimens are sewn as specified in NFPA 701. Each specimen is numbered and weighed before conditioning. The specimens are placed in a forced draft oven at 105 centigrade for at least 30 minutes and allowed free circulation of air around each test specimen. If specimens melt, it is allowed to condition them at 20 C for at least 24 hours. Each specimen is attached to the pin bar and suspended vertically in the test chamber with small weights clipped at the bottom to keep it in place. The 100 millimeter flame is placed 25 millimeters from the lower edge for 45 seconds in a horizontal position. If pieces of the fabric break away from the rest of the sample, the test engineer will record how long the pieces burn after they've separated from the sample. After flame time is also recorded along with the observations of the burn. Once the burner is removed from position, the remaining material on the pin bar is weighed to the nearest tenth of the ounce before 60 minutes of time elapse. I have provided the calculation of the percentage of mass loss. The mean percent of mass loss and the standard deviation are also calculated. The criteria for test method 1 are as follows. Fragments of the specimens that fall shall not continue to burn for an average of 2 seconds per specimen. The average weight loss of the 10 specimens shall be 40% or less. No individual specimen's percent mass loss shall deviate more than 3 standard deviations from the mean. If the percent mass loss of any test specimen is more than 3 standard deviations from the mean, then the test shall be repeated on another 10 specimens. And when retesting, no individual specimen's weight loss shall deviate more than 3 standard deviations on the retest. If a sample set does not meet the test criteria, then it has failed. This is how the test data is presented in the report. We include the weight of the sample, but also the after flame time and the flame drip time. Test method 2 setup consists of a test cabinet constructed per NFPA 701 with the top specimen rod and vertical guide wires to support each specimen. A gas burner that conforms to ASTM D5025 meeting calibration set in ASTM D5007 shall be used as the ignition source. The burner is placed at 25 degrees at the bottom of the test chamber. Methane gas 97% purity is used. A rotometer, tubing with at least 6 millimeter bore, a stopwatch, and a ruler with 1 millimeter increments. When testing flat specimens, 10 whole test specimens cut widely separated over the entire length of the sample material and cut parallel to the lengthwise direction of the material, 125 millimeters by 1200 millimeters. Multi-layered specimens are sewn as specified in NFPA 701. Only specimens that cannot be folded are tested in the flat configuration. This means when folding and hung, they do not fan out at the bottom. The specimens are placed in a forced draft oven at 105 C for at least 60 minutes and not more than 180 minutes. and allow free circulation of air around each of the specimens. If specimens melt, it is allowed to condition them for 20 C for at least 24 hours. Each specimen is tested within 2 minutes of removing it from the oven, so you have to move quickly if you want to get it into the test chamber. Samples are mounted on the rod and clipped to the vertical supporting wires. Once suspended, they should be about 4 inches above the burner. The burner is then lit with a gas pressure of 2.5 psi and a flow rate of 113 liters per hour. The burner inlets are sealed, and the flame should be about 280 millimeters. The flame is then applied to the specimen for 2 minutes and then withdrawn. Flaming fragments that fall are recorded at 0.5 second increments. Flaming once the burner is withdrawn is recorded also at 0.5 second increments. The length of the char of the specimen is measured by the length of the specimen minus the length from the top edge of the specimen to the horizontal line above which all material is intact. The test criteria are as follows. Any specimen flaming for more than 2 seconds after the burner is removed is considered as having failed. The length of the char for any specimen that is greater than 435 millimeters is considered to have failed also. Any fragments that fall and flame for more than 2 seconds after reaching the floor are considered to have failed. A retest of the material is conducted if only one specimen does not meet the test criteria. 5 new specimens are tested and all must meet the test criteria. When testing the folded specimens, the test runs similarly to the flat specimens, but only 4 test specimens are tested, and they are cut to 610 millimeters by 1200 millimeters. Again, only the specimens that can be folded are tested in the flat configuration. The specimens are conditioned the same as the flat specimens in a forced draft oven. Specimens are mounted on the rod and clipped to the vertical supporting wires, this time folded 4 times. Once suspended, they should be 4 inches above the burner. The test is run the same as the flat sample. The test criteria are as follows. Any specimen flaming for more than 2 seconds after the burner is removed is considered as having failed. The length of the char for any specimen that is greater than 1,050 millimeters is considered to have failed. Any fragments that fall and flame for more than 2 seconds after reaching the floor are considered to have failed. And a retest of the material is conducted if only one test specimen does not meet the test criteria. 2 new specimens are tested. Both must meet the test criteria. Here is the data that's included in the test report. We do include a density measurement for all our clients. As for laundering and leaching procedures, when a test material manufacturer has rated the material as maintaining a flame resistance after cleaning and weathering, it is laundered and leached. A second set of materials is tested after the laundering or the leaching, as well as the materials that are initially tested. Laundering is performed according to the manufacturer's instructions. 3 full cycles of dry cleaning are conducted, or 5 full cycles of laundering are conducted. Specimens are cut from material after laundering and conditioned as per the test method. Leaching is performed if the materials are to be used outside. 72 hours of leaching in at least 15.1 liters of 20 C water is required, with the water changed from the leaching vessel every 24 hours. Specimens are then cut from the material after leaching and conditioned as per the test method. This ends my presentation, and I would like to thank all that attended today.
Thank you very much, Salvatore. And I believe we're going to hold off questions until the end of the presentation. Is that correct, Brianna?
Yep, that's correct. We'll have a question and answer time at the end, and I'll be writing down all the questions that you're sending me on chat, and we can go through those.
Okay. So at this point, we'll turn it over to Mark Crawford from Intertech.
Actually, right now it's Salvatore Messina.
Salvatore Messina from
Yep,
Goodmar.
and yep, there it is.
Hello?
Hello, is that Salvatore?
Yeah, who's controlling the screen?
I am controlling it. Are you ready?
Oh, you're controlling the screen.
Yep. Sal, when you're ready, you are up.
Salvatore, are you there?
Well, while we're waiting for Sal, let's answer questions about on the presentation we just heard.
Okay.
So we have a question that is, can you explain what afterflame means?
The afterflame is once you have drawn the flame from the burner away from the sample. The sample will keep burning, and that's considered the afterflame. So then you start the timing once you pull the actual flame from the burner away, and that afterflame is timed, and once it goes off, then you shut off the stopwatch.
Another question is, when would you use method 2 versus method 1 for NFPA 701?
The method 2 and the method 1, the test method 1 usually applies to fabrics like curtains and draperies, other window treatments, and it's usually used for fabrics that are less than or equal to 21 ounces per square yard. Test method 2 usually applies to decorative materials that aren't considered fabrics, or fabrics that have densities greater than 21 ounces per square yard. We usually do a density measure here at Intertech for the clients if they can't provide us with the densities.
Okay, and could you please explain the leaching process?
The leaching process is 72 hours where you use a filtered water, very clean water, that is put into a large container, at least 15.1 liters. You would put the material into the container and fill it up. The container, the water that goes into the container has to be at 20 degrees centigrade.
I can't hear it when I don't have it on speaker.
And the material is left in there for 24 hours. At that point, then you would empty the vat or the tub that the material is leaching in, and then replace the water with 20 degrees centigrade water again. You do this until the 72 hours is up. So it's 3 changes of the water at 24-hour points. Once that's finished, then you pull the sample out cut it to the links for the test, and then test the material. Of course, you have to condition it afterwards. So it's put into the forced draft oven for the specified amount of time in the NFPA 701.
Brianna, can you hear me now?
Yeah, is this Sal?
Yeah.
Perfect. We can hear you. Okay.
Okay.
And we'll save the rest of the questions till the question and answer time, and we will let Sal talk about ASTM E84.
Wait, what? You can hear us there?
I think my approach will be different than Mark's. I'm more concerned with just giving the broad outline of the test and tie in more of what the standards require. The ASTM E84, this is meant to test all materials that are used inside a building. When you read the building codes, the material is classified as interior finish. And interior finish is anything that's applied to the walls and ceilings of the building. So 1,000 years ago, they found that some fires had spread very rapidly through the buildings, and I believe underwriters came up with the original test, and the gentleman involved was Steiner, and most of you know this as the Steiner tunnel test. And the concept is to measure the rate of burning. And the peculiarity of this test is that you're measuring the rate of burning while the specimen is in a horizontal configuration. So basically, you do have a horizontal flame test. So the test specimen, which is roughly 2 feet by 24 feet, is sitting in the ceiling of the tunnel. And the flames are hitting the face of the specimen, and the flames project about 4.5 feet down the face of the specimen. And the calculations for converting to flame spread are based on the remaining 19.5 feet. At the end of the tunnel, there's a smoke monitor, and this is measuring the smoke given off. So the test gives two values. The rate of burning is expressed as a flame spread index, and the smoke given off is rated as a smoke developed index. Now, when you read ASTM E84, you will not find anything that describes whether or not the test passes or fails. This is not unusual. As Mark pointed out, in the NFPA 701, that document does have specific pass-fail criteria. When I talk later about California Title 19 small-scale test, that also has a specific pass-fail criteria. Now, the ASTM is cited in the various building codes, and the building codes have set up a system. The best classification is the A classification, where the flame spread is from 0 to 25, and then as you go down the column, the B classification, the flame spread is from 26 to 75, and the worst classification, which is C, is a rating of 76 to 200. And in all of these ratings, the smoke development remains the same. For a class A, B, or C, as long as you stay within 450 for a smoke developed, you'll meet either of those classifications. Some building codes have even tighter restrictions. The New York City building code for smoke developed has a limit of, it ranges from 25 to 100. So what you see now are the basic rules that apply, I would say 99% of the time, and you do have some odd local codes which may be more stringent. In addition to the ASTM E84, there are other tests specified by NFPA 265 or NFPA 286. These are, again, interior finish tests, but the specimen, instead of being held in a horizontal configuration, is held in a vertical configuration. And these tests can be, quite more severe than the ASTM E84. However, that is not really the topic of our discussion today. I just thought I would point this out so you would have a bit of general background information if anyone ever mentions the NFPA 265 or the 286. But generally in a sprinkler building, the ASTM E84 is the code of choice. This is just a rehash of the way the test standard was developed. Back in the olden days, all tests, even the NFPA 701 that Mark had talked about, all the tests were based on a form of testing a cellulosic product. For the NFPA 701, we were talking about fire retardant treated cottons. And for ASTM E84, we're talking about fire retardant treated wood. Wood was the interior finish of choice back in the early days, and it was easy to improve the fire resistance of wood by adding a fire retardant treatment. Same thing holds true for the cotton material, which was the predominant material. You had to have a flame retardant treatment to improve its characteristics. The rationale of the ASTM E84 test was to burn a red oak material which arbitrarily gives a flame spread value of 100, and it arbitrarily gives you a smoke development rating of 100. You then burn real materials, and you compare the burning rates and the smoke rate versus the red oak, and this gives you your smoke density values. In the real world today, you have a zillion products that do not burn as cleanly and as evenly as wood, and the ASTM E84 committee came up with a formula, and you plug in the distance burned and how quickly it burns, and that formula gives you a smoke and a flame spread index. But again, it's not that same simple formula that was used when you were comparing treated wood versus untreated wood. This is just a chart showing that giving you a quick example. The red oak arbitrarily burns in 5 minutes the entire length. You give it a flame spread index. If you have an actual sample which burned faster than the red oak, you'd have a 200 flame spread index. Below you see again, the red oak burns 5 minutes. It gets a rating of 100. And the actual sample burns twice as long as the red oak, and therefore it gets a better flame spread index, a lower value of 50. This is just a description for interior finished products. If you bond the material to a non-combustible board, you'll probably get a rating that might be 5 to 10 points better than if you bonded the material to a 5/8" gypsum board. It, again, depends on the actual building application. Some manufacturers who use the non-combustible board, the theory is if they have a product, they're telling the world what the raw value is of that particular product. On the other hand, the customer might say, well, I'm going to bond this to gypsum board, so give me a gypsum board rating rather than a non-combustible board rating. This is just a repeat of the classification system. These are some typical results for a vinyl type product. If the product is used in the building but is not bonded to a surface, then the test is done over some chicken wire supported by some 1/4-inch rods. So you can see here that the flame spread index was a 40, the smoke developed was a 300, and therefore the product wound up with a Class 2 or B rating. The data summary was used to calculate the flame spread values. This is another textile product which shows a result where it was adhered to the gypsum board. Normally, you'll get a better value when you bond your product to a backing. I think most of what we see for unbacked materials are outdoor screening materials, and sometimes when you have a large wall surface area where the product is being held suspended without being bonded to the wall. And I think, as Mark pointed out, the appropriate test for the hanging material is NFPA 701, yet throughout the land, many fire marshals, all they know is ASTM E84. So you have a conflict between satisfying a fire marshal and doing what the correct test is. Sometimes we recommend both tests, doing the NFPA to protect yourself in the case of product liability, and the ASTM E84 to satisfy the fire marshal. California Title 19. Before I get into the nuts and bolts of this procedure, California Title 19 holds a very odd place in the world of fire test standards. If you Google Title 19 and come up with the full document, you'll find that there are 3 tests specified by California. They have a large-scale test, which is similar to NFPA 701, test number 2. They have an intermediate test, which supposedly is for synthetic materials. And they have the small-scale test, which is the topic of today's discussion. In reality, California ignores or does not enforce the large-scale test. They do not enforce the intermediate test. The only test that they use to rate a material to issue a certificate from the fire marshal's office is the Title 19 small-scale test. Again, this is a test based on testing treated cottons. If you read the rule book for California Title 19, you'll see a lot of verbiage about sending in samples and sending in chemicals. That can all be ignored. Basically, all California is concerned with that the product that you deliver does meet their test. This is a simple, small-scale vertical test. We hold a 3x12 strip inside a metal frame, and we position a 1.5-inch flame underneath the specimen for a period of the 12 seconds. As you can see, about 3/4 of an inch of the material is impacted by the flame. And the test has two basic measurements. We measure the char length, and we measure the afterflame. In fact, this reinforces what I've been saying. When you burn a piece of treated cotton, it doesn't really break, it chars. So in the real world, other standards have changed from char length to burn length, but many of the standards still use the term char. You know, in fact, after this conversation, I'm going to go back and make sure that California does use the word char and not, not burn length. But we're talking actually about the same thing. The char length or burn length is the total length of the section that is degraded by the test flame. The after flame, when we remove the 12-second test flame, if there's any continued burning on the test specimen itself, that's the after flame. Again, reading the rule book, you might have difficulty in picking up what we're stating as the maximum values, which are, so for any individual test piece, if you have a reading over 6 inches, the product fails. If you average a group of 5 for the after flame in either the machine or cross machine direction and you exceed 4 seconds, then you will fail the test. And I think on our test reports, and we've made the note up there, this has been the version and the values that were given to us by the state of California back in 1993, where I actually was at the meeting held in the fire marshal's office. And we continue to check with the local or current fire marshal on an annual basis. And I think you'll hear a lot that California is playing around with maybe changing their procedure or maybe going over to NFPA 701. But rest assured, as of today, these are the values that California is still accepting. The California process is a bit different. They don't just take self-certification, and self-certification, also includes, sending in samples to an independent testing laboratory. What California requires is that you send them a test report from an independent lab. And of course, you wouldn't send it unless the fabric passed or the material passed. And when you send it to California, there's a fee application process, and California itself does have the right to perform the test on the same product. What we recommend to people, if you're going to send a sample to a GovMark or to Intertech, let's say cut a yard of material, send GovMark, or maybe it's cut a yard and a half. Send GovMark, send to the testing lab a half yard, send to California a half yard when you get your results back from the testing laboratory, and just as a keepsafe, hold on to an additional piece in case there's a dispute in the results. Over the years, I think that it's very rare that we have any disputes with California. In fact, I think they have a GovMark tester, I think, in the lab. So that's the certification process. You have your sample tested by an independent lab, and then you send a sample of the same material with a copy of the lab report to California, and they will issue a certificate after they do their own testing. I think quite often they might just be happy with the independent lab report. They might not even do a test, but they still have the authority and right to do the test. This is what I had said at the beginning of the presentation, that when you read the rule book, you're going to find 3 tests: small scale, intermediate, and large. And California has limited, to this point in time, only the small scale test. this is the after flame and the char length values that we had given previously. Something we have to really pay attention to in our lab, if there is any product, and this happens quite often with some synthetics, you'll see that the product is really not burning. It might burn maybe 3 inches, and then the remainder of the product will sort of melt away without any flaming. And California says that if there is such melting, then that's not considered part of the char length. So that's something we have to really, in order to protect our clients, we have to really pay attention when we get some synthetics that will melt rather than burn. This is a typical test report for the California Title 19. As you can see here, the after flame was 2.6 in the warp and 1.7 in the fill. So these were well within the 4 seconds average. And the char length, each individual char length, both in the warp and fill, is well below the 6-inch maximum. Afterglow is considered part of the test procedure, but there is no limit on the afterglow. When we test some cottons or some, again, treated cottons or leather, what happens after you remove the test flame, there might not be any after flame, but there'll be some glowing particles. So the test continues until the glow extinguishes, because as the material is glowing, it is burning slightly, and it will increase the char length. But as you can see in this sample here, there was 0 afterglow. Oh, this is a sample of a that failed the after flame. It had 5.8 versus the 4 seconds allowed. The char lengths were all good, but I think most of the failures we find at today's market are more related to after flame than char length.
Thank you, Sal. Now we have questions that have been typed in, and we can go through them quickly. We have about 15 minutes left, and I'm just doing them in the order right now that they were sent to me on chat. So this goes back to the NFPA 701. If you bear a 701 certificate, does it outweigh the authority of the local fire marshal? Okay, can everyone hear me again? So we're going to, I'll repeat the question. If you bear a 701 certificate, does it outweigh the authority of the local fire marshal?
The fire marshal will make all the decisions. So if they decide that their certificate is not what they require, then they may ask for another test to be done.
Okay.
We
Another
have clients.
question.
Oh, can I?
Oh, no, go ahead.
I'll say a little more. If sometimes you'll run method 1, they'll ask that you run method 2 instead of method 1. Some of our clients will test both method 1 and method 2 just to make sure that they'll fall under the regulations of the fire marshals in the different cities or states.
Okay. Next question is, I've seen banner manufacturers state that their banners passed NFPA 701 test. 1 only. Is that valid, or does it need to pass test 2? This is for a 13-ounce 13 banners?
Again, the fire marshal will make that decision, and you can test to both the tests to make sure that you'll be safe in all the different states or cities. If it's a 13-ounce, usually test method 1 is the preferred method, but sometimes they may ask for test method 2.
Okay. We have another question for the ASTM 84. Do fabrics with a topical treatment typically perform as well as those that are IFR?
I don't think it's a question that can be answered. Only the test will tell.
Okay. What is used currently to measure smoke density in the ASTM 84?
There's an optic system at the end of the tunnel, and there's a light beam that is affected by the smoke in the tunnel. And then there's a formula which takes the value that the light beam sees. There's a detector on one side, and that calculates out to the smoke developed index. I'm curious as to the nature of that question.
Whoever asked that question can ask for further.
I was just curious what prompted that question. Let's move on to the next one, then maybe that person can get back to you with the more information.
Okay. In the California Title 19, isn't Title 19 nothing more than NFPA 701 of 1989?
Yes, except for the pass-fail criteria. It is the same exact test procedure. Yes, that's a keen observation.
Okay. Are awnings containing graphics controlled under the same NFPA 701 test? If so, do the graphics being applied or the fabrics containing graphics have to be tested similarly?
Hello?
Hello, can everyone hear me still?
I can hear you.
Okay. Let me repeat that question.
Okay.
Are awnings containing graphics controlled under the same NFPA 701 test? If so, do the graphics being applied or the fabrics containing graphics have to be tested similarly?
I would say that the graphics need to be tested to the NFPA 701, and the material without the graphics would need to be tested. Graphics may affect the material itself.
Okay. What's the procedure for the NFPA 705 field test?
The NFPA 705 field test is a test performed out in the fields. They want to get in an area that doesn't have any wind or drafts. It's a 4-inch by 1/2-inch sample. It's suspended vertically, and they take a match, light it, and hold it underneath the sample for 12 seconds, I think it is. The burn is measured after that. It is not to be correlated with the NFPA 701.
Mark, can I speak on that also?
Sure, go ahead.
When they wrote the NFPA 701, I think the 89 was first updated in 1996, and I think Mark touched on it also. We measure after flame as part of the test method number 1, but there is no pass-fail criteria for after flame. It's an academic measurement. However, when they do this NFPA 705 field test, if you have a few seconds after flame, the field inspector will reject the product. So you've got to, even though you're allowed unlimited after flame in the 701 test method number 1, it might be prudent to make a product that has reduced after flame. End of my speech.
This is Mike. I might also interject that we've heard of instances where the fire marshals out in the field have been using butane lighters of varying lengths of flame, and also following the flame up the fabric. So the field tests in that instance are not at all like the laboratory tests, or as the NFPA 705 is designed. That is my understanding.
Yeah, that's a problem. NFPA 705 is a real problem.
And is there any recourse? Is there any way of of addressing that with the various fire marshals?
The only way is to go hat in hand and hope to convince them that a laboratory report. If you read the 705, I think there's some verbiage in there that says that a good laboratory report should be acceptable. But again, if you have a local fire marshal who has his mind made up, it's a difficult situation. It's a real life business face-to-face confrontation that hopefully you can resolve in your favor.
Okay, we have a couple more questions, and then we'll be signing off.
Biani's done a very nice job.
Oh,
I'm going to compliment you before we get to the closing line. Go ahead. I'm sorry.
Oh, thank you. Could you please review the difference between char and melt in the California Title 19?
Oh, yeah. Let's envision that we have this swatch of fabric that's suspended in the test chamber. And let's not put a test flame. Let's put a match. This way it's symbolic. It's easier. If you put a match under it, if you have a lightweight polyolefin, it will not burn. It'll just shrink away from the flame. So it might shrink maybe 5, 6, 7 inches. So California is saying, we don't care. In other words, if we said we have a maximum of 6 inches, in actuality, we qualify the report and we say, you know what, we found 7 inches, but it's not burn, it's melt. And California will accept that, even though it went above the 6-inch mark. So that is melting, it's not burning. The problem is sometimes you might have a fabric or material that when you put the flame under it, maybe you'll see some flaming for the first few inches, and then maybe beyond that, you'll have some shrinkage. So that's where it's difficult to assess that fabric. But again, if a portion is melt, then the 6-inch rule does not apply. If the melt that pushes you beyond 6 inches is a melt. It's a difficult concept, but basically, the simple way is if it's melting and not burning, you cannot fail the 6-inch rule with California.
Okay, and this will be our last question. Do GovMark and Intertek see more specific state-formed tests arising in the U.S., like the California Title 19 or new nationwide all-encompassing FR tests, like NFPA 701?
Mark, you want to handle that first?
Geez, I think we do a wide variety of testing, so we get a little bit of both. It's just dependent on where they're actually wanting to maybe erect a tent or where the material is going to be put inside a building.
From what we see here at GovMark, there are the known locales that enforce their own test procedures. The city of Boston has a reputation. The state of California, We're seeing, it's funny, we've been in business since 1971, and I can tell you how many tests we've done for products going into the world, the Twin Towers. Now they're building the new tower, which is run by the New York Port Authority, and all of a sudden we're getting testing. So again, since 1971, I can count on one hand how many tests we have. So I think the point is, if you have a fire in a particular locale, then that spurs that particular local agency to start coming up with standard tests, or maybe start coming up with their own tests. In fact, Boston, I think there was a famous fire that went back into the 40s. So that's I think it's about the Coconut Grove fire. It was a nightclub in Boston. So that spurred Boston to get more involved with fire testing.
Well, at this time, I'd like to thank both Salvatore and Mark for all that they put into this webinar. And for those of you online that have joined this meeting, we thank you for joining it. And our next webinar will be on June 29th, and it will be covering latex printing. So thank you once again.
Thank you all. Have a good rest of your day.
Thank you very much. Bye now.